everyone. Welcome to Risk Roundup. The sophistication, speed, and scale of attacks are evolving rapidly in cyberspace. As new attack vectors are being introduced from cloud services, Internet of Things devices, and more, they are creating security blind spots and making threat detection more difficult to humans to tackle on their own. Since the task of responding to these attacks in real time has become enormously complex, to offset this risk, artificial intelligence, in short referred to as AI, has become an indispensable tool for security. Now, as trends are driving to automating security decisions to discuss one such autonomous network security solution, I'm delighted to welcome Bart Shields and David Gell to Risk Roundup. Bart is the CEO of Olympus Sky, and he's based in Poland, and David is the Chief Marketing Officer. Welcome, Bart and David. We're honored to have you on Risk Roundup.
Hi, and we are both glad to be here. Thank you.
Wonderful. Wonderful. So there is no doubt that over the years, hack attacks have been causing massive damage. Why do you think is our current approach to cybersecurity, especially network security, not effective?
Because it's very complex. It's human centric. It's inflexible, and it costs a lot to maintain. And what happens is that people either don't have security, or they have security holes because they're trying to take shortcuts. And all of these solutions that are based upon the traditional way of managing security, they are using it in ways that PKI, which is the traditional method, was never meant to be used. It was just never meant to do things at IoT scale.
I see. So this is more, what you are trying to say is that this is more because of the IoT Internet of Things that it has the whole ecosystem that has emerged. That is a cause that, because now we are not just talking about human to human communication, but now it is human to machine communication and machine to machine communication. So is that the reason why we are facing challenges? And you just said that, so far it was all human centric, but now because of these IoT devices, now it is not just human centric. Machines will have to do everything on its own as well, and the whole fundamentals are changing. So is that one of the reasons that we have to now move from human centric approach to machine centric approach?
Yeah, but I was actually saying more than that. I was saying that the administration of PKI, of the traditional way of doing things, is human centric, and as a consequence of both that as well as the cost of these certificates, these certificates are often there for either the lifetime of the system, or at best the suggested time to replace them is every 6 to 9 months. So that means that for 6 to 9 months, best case, that you have a static target that the bad guys can just go, that they can keep attacking and attacking until until they can get through. And there's a statistic that we recently uncovered, which was like 95% of all breaches are not a consequence of the technology breaking down, but it's a consequence of a human being doing something stupid at some point in time.
Sure, no, that is fair and I understand. But now the point that you made about the certificates, that the traditional approach to certificate and how sometimes they are there for lifetime. Can you explain that process? How does that work? And if it's just a certificate, then how does it validate the authenticity of the security, or that how does the certificate on its own, if I acquire a certificate like SSL certificate, and then it makes a note that I have that certificate, how does it prevent the security, or how does it prevent any attacks happening on that because of that SSL certificate? And how does it need to change? Because like you said, it's dynamic, and sometimes it is not replaced for the entire lifetime. So where do you see the challenges emerging in this, the whole model that is based on the certificate?
I'm going to let Dave take this.
Sure. One of the ways to think about certificates is to use an analogy, and that's sort of the keys to the locks on your home. And a certificate is really the master key, okay? And when we look at how certificates are administered today and used today, there's a couple of problems, right? One is that oftentimes this master key or certificate is shared across many devices. Fairly recently, even the automakers were using a single certificate to secure communication across an entire model year of vehicles. And so if one got broken into, they're all vulnerable. Okay. The other, concept to think about is if a master key is stolen, you need to have some way to replace that, right? Because that thief, that hacker, can then create, ongoing damage. So the deficiencies of having a static master key that's shared across many different devices is a problem. It causes a threat surface that is easily exposed by hackers.
Yes.
What we have more and more is that the replacement of those certificates is expensive, it's slow, as Bart was saying, and ultimately it's human-centered, right? So a human actually has to go in there and say, I'm going to revoke that master key. I'm going to remove the master keys from everybody's keychain, and I'm going to give you a new one. And that's the problem we're trying to solve.
I see. So how do you see your solution strengthening the security for not only the IoT ecosystem, but the entire network security, irrespective of whether it's IoT or whether we are talking about autonomous vehicles? How do you see it strengthening that?
Yeah, we do two things with our approach. One is we want to eliminate the concept of having a master key, right? So we want every communication relationship to have its own master key. So that, for one, reduces this threat surface, right? So if a key were to be compromised, you would only be vulnerable for a particular relationship or communication channel, right? All others would be safe.
When you say, sorry to interrupt, so now when you say you want every communication to have its own security key, will that also include like any email communication, or human to human communication, human to machine, or machine to machine communication? Will it involve everything that goes on the network?
It can, really. So any electronic communication, whether it starts from a smartphone and goes to the cloud, or as we're currently focusing on machine to machine, right? If it starts with a robot in a factory and goes to a centralized controller, right? Any type of electronic communication can be secured using an old approach, PKI certificates, or this new approach that we're bringing into the market.
I see. So what kind of solutions you are offering? Is it one standard solution for all the machine-to-machine communication?
Well, what's really interesting is we have a core technology it's really a breakthrough in how to think about a master key. And it's a breakthrough in how to think about the ways in which you can autonomously change that key without involving a human. That's such a fundamental breakthrough that we can apply it in a variety of different ways. We are starting out with applications where we're securing machine-to-machine communication, as you're saying. We're working with a company in Germany that is in the real-time, high-reliability wireless business for factories. They're helping factories with reconfigurable robots to secure their wireless communications in a reliable way. Our solution is in that product, okay? And so that would be an example of a machine-to-machine security solution.
So what is at the core of your technology? You said it is, fundamental, it is revolutionizing. So what is it at the core that makes this technology that you have developed so effective, if we say machine to machine communication or human to machine communication?
Right. Well, I mean, I'll take an overview, and then I'll have Bart describe some of the details that we can share. But really, again, it's a new way to think about a master key, and the concept and the problem that we have solved is, how do you share a master key? How do you share credentials that are needed to communicate without exposing a secret, right? If you and I would like to communicate and we decide that we're going to encrypt that communication, we're going to secure that communication by using a key, how do I get you the key? How do I hand it to you? So there's this concept called zero knowledge. And a zero knowledge approach is a mathematical solution that allows me to share a key with you without having to expose a secret. So in a sense, it sounds a little bit like magic, but what it allows us to do in the end is for us to communicate securely without me having to expose any secrets to you that can be intercepted and hacked.
So let me understand this. Right now, let's talk about human to machine communication. I'm trying to send email communication, not to you, but even if, let's say, human to human communication or human to machine, I'm trying to send a communication to some smart device in my house, or, trying to turn on some lights, or, telling the thermostat to turn it on using, that communication technology that you have developed. So
Right.
how would that, process work? Is it, when you say every single communication gets secured and it has its own encryption, would it secure if I say send a message?
So every relationship. So if you have your person, you're sitting at your computer, you want to email, you want to contact your home, you have a separate relationship with with your home than you might have with something else. And so everything that you have a relationship with, you're going to have a different set of security credentials for. And let me back up a step. So when I first conceived of this solution, the problem that I was trying to solve was twofold. First, I said, let's come up with a way where we don't have to rely on a centralized authority to give us that master key. So that's what Dave was talking about. And then I said, the second thing that it needs to do is it needs to be able to isolate the security relationship of each relationship, of each connection, separate from the other connections. Because if you look at a lot of the hacks, whether it's a vehicle hack or whether it's a hack, the now famous hack of the Las Vegas casino in July of 2018, where they got into a fish tank sensor, and then they downloaded all of the high roller, the database. Those hacks are enabled because once someone breaches the system, even on an edge node, because all of the keys in a typical system are derived from the same certificate. Once they have a little bit of information about that, then that basically gives them the keys to the kingdom. What we do is, because every security relationship we have has a different set of credentials, even if somehow one node is breached, that gives them no knowledge, no insight into any other set of credentials in any other part of the system. Everything is unique, and it's not just unique between the different relationships. It's also unique between the different sessions. So unlike PKI, to where your credentials are static for 6 months, for 9 months, for a year, sometimes forever, our credentials are refreshed on a periodic basis, and that can be once a minute, it could be once an hour, once a day, once a week. It's whatever you as the customer side is right for your system. So they're not only more secure because every relationship is unique and has nothing to do with the other ones. It's also more secure because it's constantly being refreshed. So it's not a static target.
Sure. So I understand that. So now your focus is on relationships and credentials. But what about the content that is being communicated? What about the data that is being communicated? How do you ensure that the data that is being communicated between two, entities relationship, that data is secured? Is there any process to ensure the security of that data?
Yes. So that's twofold. One, that's protecting the data, which that's what the encryption does. And then secondly, because we use zero knowledge, part of zero knowledge is to authenticate both sides. Usually that requires a third party. And one of the problems that we had to solve, because we didn't want to have to require a third party to authenticate both sides, is we do self-authentication. And the way that we do that is every frame has a message authentication code. So that ensures that what is sent is what is received. So when the receiver receives that data, because of both the data was encrypted and because it has this message authentication code, then they know that the integrity of what is received is valid.
So that authentication code, what criteria does it follow? Is it whatever content is there? Is there any analysis happening before it gives that authentication code that it needs to go forward? Like, right now, if you see that the system, how the settings are, and based on that, the authentication of the outgoing communication happens. So here, I mean, a lot of times what happens is that, safe content is labeled as unsafe, or unsafe content is, labeled safe, because all they follow is the settings. But that is not enough to ensure the security of the data that is being, sent, even if it is encrypted. And even if it is, having the authentication code, there needs to be more, more into the process, which ensures that what is malicious or what is safe is actually what is safe and what is malicious. Because just by ensuring that the settings are right or the authentication code is given to send out that communication, it is not enough to ensure the security of the communication of the data that is
okay. So let's be clear about the product we have. So what we do is we ensure the integrity of the data, and so we have additional parts of a encapsulating system that does more than just that, and if we have time, then we'll talk about that, which is our security solution Zeus, which is built on top of AKM.
I would like to. Can you explain it?
But let's finish this first. So what we're doing is we're ensuring that what is being sent is what was meant to be sent. Now, if the data was already corrupted before it was sent, we don't have any awareness or any way with the AKM protocol, with the Autonomous Key Management Protocol, to detect that. We're just ensuring that what the sender sent is what the receiver receives. And then we have an encapsulating solution that goes beyond that, where we get into intrusion detection and those sorts of things. But the first, the primary goal of our core technology is encryption and integrity.
Yes. Yes, I hear you. But right now, if you see the way we encapsulate, this data that is being communicated, that's where a lot of, security vulnerabilities emerge, because anybody can, manipulate that data. Anybody can change the header, and
No, they cannot, because part of what we encrypt is we encrypt our headers. So they're not going to change that. I mean, they might change the encapsulating headers, but they're not going to change the header of the security protocol.
So once by using your technology, your process, the encapsulation happens, nobody will be able to open that until it reaches the endpoint.
Right. And we incorporate the concept of a replay counter, which implicitly ensures that somebody just can't do a replay attack.
Yes, I understand that. So what kind, where are you planning to go with this innovation? What different applications you are trying to develop, or what industries you are trying to protect using this core technology that you have developed?
Okay, so I'm going to give an answer, and then I'm going to hand it back to Dave. So the short answer is everything. That's the problem with the technology we have, is it's so ubiquitous in what it can apply to that it's difficult sometimes to focus, because we feel like this technology could change the way the entire world does security. And not only that, because of how we do it, it's also quantum resilient, which by the way, the moment that quantum computing becomes real, the moment that there's commercially available quantum computing machines, that's going to obsolete the way that security is done as it's done as of today. And our methodology is quantum resilient. But I'm going to hand it back to Dave now.
Okay.
Yeah, so that's you can hear from the visionary where we want to land in a few years from now. But at the moment, right, we've got to figure out where we are going to focus. I mentioned earlier that we're working with a company in the industrial IoT space, and that's a great application for us. Machine-to-machine communication, mission critical, safety critical systems that are highly dynamic. They're moving. Okay, so you have physically moving in many cases. So you have complexity, and you have machine-to-machine communication where inherently there is no human in the middle, right? There's not somebody that's necessarily there to change passwords and in our case, certificates. So those are some of the characteristics of our early application space. So industrial IoT is one market we're working in. Another is transportation. So again, very complex networks, physical systems in motion, reconfiguring. This can be anything from train systems to autonomous drones. So you can imagine drones flying in a fleet over various ground stations, communicating between themselves or between other points down on the ground. Very complicated system. And the ability to secure it using a static credential that's shared across everybody, it just doesn't work. It's very vulnerable. We're working with some of the biggest names in aviation who have come to us and said, look, we can't find a solution to this problem. Show us how we can apply yours to solve this, because there's nothing else out there. So that's another good application for us. And then just wrapping up, in the long range, we have opportunities not just in securing communication data, but we look at data at rest, right? So we can secure databases, we can secure files, and even beyond that, we have the opportunity to look at applications like a secure supply chain and asset tracking. So as a complex piece of machinery moves through its journey from chips to modules to a completed system that gets fielded and repaired, ultimately retired, the integrity of that and the authenticity of those parts, hardware and software, that's actually something we can also secure.
Yes.
So very broad brushstrokes here, but you can see we're starting with communication security and we're working our way
Yes, no, of course, there are a lot of many opportunities, industrial IoT, and as you described, autonomous vehicles and drones and all kinds of, different applications can emerge from that. But because your solution is based on autonomous, a network security. So once, let's say, your it is system is autonomous and it decided to suddenly not follow any orders or not follow what it was supposed to do, because once it becomes autonomous, then we have no control over how it goes forward. And if you want to, would there be any off switch if there is a place where we reach where we decide, okay, right, and there are security, actually, there are security risk emerging for us while we are using these autonomous systems to secure us. It could make us vulnerable as well, in the coming years, because we just don't know once it becomes autonomous where it would go, what it would do, because at that point humans will have no control. So at that point, would you have any control or any way of turning it off?
Yes, yes. So what we have is, just like when we're provisioning, when we're initializing a relationship or a set of relationships, it has to have a secure method to do that. So the provisioning module, whether that's some handheld module you directly plug in, whether that's the back-end server connecting across the cloud into your network and doing it, whatever that is, there's a provisioning relationship between the provisioning module, and I'm talking about software now, I'm not talking about an actual piece of hardware, between whatever that provisioning module is, wherever that is, and in the end module and the end set of modules that it is working on. So it has separate relationships. So if it needs to go in and shut those relationships down, that is the backdoor way to do that. It's also the backdoor way to that allows, getting back to what I said before about this larger system, Zeus. That's also the way that it can automatically repair a network in case there is a breach. It will use that backdoor, go in, update the security credentials for the affected nodes that there might have been a breach on, and then effectively halt the breach in midstream. We are the only technology that I am aware of where our technology by itself, it's all 5 pillars specified by NIST for what a complete security solution is, which is identify, protect, detect, respond, recover.
Sure, no, that's good, and I'm glad to hear that. But we are here talking about unknown risks that could, emerge, because at this point we do not know what kind of risk will emerge from any autonomous system. While you say that you have kept a back door, it is possible that this autonomous AI system, the AI will become so intelligent enough that it will realize that there is a backdoor and that we could be shut off at that point. I mean, these algorithms could become self-improving, and then it detect that there is a backdoor where we could be shut off. So let's just shut off that backdoor. That's a possibility too. So we are talking about unknown risk, and we hope that none of this will become a reality. But I'm just visualizing if those kind of scenarios emerge, and if the backdoor is shut off, what will we do? How to shut it off?
Well, for a system to do that, and this sort of sounds like Rumsfeld, where he's talking about known knowns and known unknowns, and but anyway, so it would be working against itself because it has to maintain that back door with those credentials in case it needs to replace a node, in case it needs to add a node, in case it needs to delete a node, or in case it needs to repair the network. That that back door is critical to maintaining the integrity of the system.
Sure, but we are talking only about a limited scenario here, that it will be focused only on the components within the system, or the modules and backdoors. We are not thinking about what an algorithm could do when it starts interacting with other algorithms. The unknown unknowns here are way different than what we are talking about here in geospace. We are talking about an intelligence system, an entirely new intelligence species that we are creating from scratch, and we will have no control once it
Yeah.
becomes autonomous, and once it starts communicating with other algorithms. These are big questions that will need to be sorted out, that will need to be answered. And every country needs to focus on that. All system developers needs to focus on that. If we are developing autonomous systems, then we also need to think about what could go wrong, how it could go wrong, and when it could go wrong. And we have to think of all possible scenarios, because once we let these systems loose, and loose in the sense that once it is implemented and once it starts functioning on its own, then it may be too late, that we will have no control over that. So the reason I'm asking all this question is because it is not just about what we are trying to do in enhancing our network security, but by doing that, what other risk we could be bringing to our entire cyberspace, to our entire geospace, aquaspace space, because everything is connected, and these algorithms eventually are going to talk to other algorithms on their own without us putting those commands in there. So we
Yeah.
have to prepare for all these
So
scenarios.
yes. So taking a step back and looking at it from the broader perspective, and not just whether or not we have a Terminator sort of end game, but the double-edged sword of having a technology like this is that because it of the way it's architected, it can keep the bad guys out, but if you're a bad guy, it can also keep the good guys out from monitoring you.
Yes.
But that's the nature of progress. I mean, there's I've thought about that a lot. But that's just the way. I mean, not sure what. I mean, we can't live statically in fear of what ifs.
No, we don't have to live in fear, but we have to visualize all things that could go wrong. And I mean, it's possible that we may not be able to visualize or think about all of those things that could go wrong today. But we do need, that's why, to create a system so that as we think more, that we keep the system dynamic, that as we think more, we can, fix that system, fix that algorithm, so that we have some control over it. Until this is a new emerging field. It's like, it will take some time before we will be able to identify all securities that could emerge from any autonomous system, not just your system, but from any other system that could emerge. So these are just, things that we have to start thinking about where it could go wrong. Because yes, I mean, it's great to have an autonomous system for security, but at the same time, what security vulnerabilities could emerge from those autonomous systems, that is also something I would like to start thinking from today, so that we don't end up in a scenario that we are hurting ourselves and we lose control over our entire human CAGS ecosystem. That means anything that runs on these algorithms, they all connected.
Yeah.
So having said,
So taking that a step further, there's nothing to prevent. Like, let's say that you have a chain of trust, and you have an ultimate provisioning authority at level X, and level X, keeps track of things at level Y, and then level Y keeps track of things at level Z. If a level Y is autonomous, then it just might sever its relationship on its own with the level X. There's nothing that we can do that prevents that.
is that a good thing that we will not be able to prevent that?
I mean, if I thought it was a realistic problem, then there's things that we could do. I mean, we could encrypt that relationship
How do
so
you?
only X had the ability to unlock
Let me,
that relationship. But short of that, there's that I haven't put that level of I don't want to say paranoia, but I haven't put that level of concern into the architecture. I'm just
No, I mean, but it's not paranoia. Believe me, when it's come to AI, this is an entirely unknown field. I won't call it being paranoia. I think we have to be very, very cautious in every step that we take. So I would urge that put some more thought into where it could go wrong, what kind of relationship security you need to maintain, so that we don't end up in a scenario where
yeah,
we could hurt ourselves.
let me jump in for a second here. So I appreciate the discussion, appreciate where you're coming from, and you're right. We do need to be thoughtful about it, and I think in many ways we have. I think another way to say what Bart is saying is that although you can never eliminate all risk and all possibilities, it's really about scope and containment. Okay, so the scenario that you're describing, where autonomy on the machines, they begin to communicate in different ways, they learn, they adapt, and it leaves our control. With our architecture, and we don't need to go into detail, but with our architecture, that's actually not a possibility. It's really critical for a lot of the applications that we're working with to be highly structured, very compact code, extremely deterministic because it's time sensitive. So what actually goes on the device itself does not learn, expand, and create new functions by itself. It is structured deterministic software, right? It simply doesn't have the ability to do anything aside from what we program it to do. So if you go backwards on, when we talk about this management channel, okay, I think backdoor maybe not the best word, but management channel. This is where some of the intelligence is, and we've developed an analytics system that allows us to assess risk by feeding back data from all of the nodes to help alert human administrators that there may be an issue, right? And the ability to configure, okay, what's the response? Is there an automatic healing of a network, or would you like to manually decide whether networks are being healed? So all along the way, with our intelligence, with our autonomy, we're providing the opportunity for a user to say, look, I prefer to be in the loop, okay? And it becomes a deployment choice. So there are, architecture decisions we've made that address these concerns, and then there's always opportunities for breakpoints if a deployment, is more sensitive in that way. So.
Yes, of course, and I'm glad to know that. So, what would you like to tell our global viewers and listeners about your products, about your core technology, and where you are going, and how you would like them to reach out to you if they have any questions?
Sure.
Yes. Dave, you want to take that first?
Sure. So we're a small and growing company. So partnerships are always something we're looking to expand on. We've described some of the value that our technology can bring out to certain markets, industrial IoT and transportation. So we're certainly looking for additional partners who are interested in exploring the opportunity to work together. So companies that are in perhaps OEMs, product manufacturers, resellers and VARs. And then as any company, of course, we're always looking for expansion capital as well. So happy to talk to investors and other sources of growth capital.
Great. Anything you would like to add, Bart?
Nothing more than I honestly believe that that whether it's the technology that we've formalized, or whether it's going to be something that is like it, that the end of PKI is well known, and it's coming, and we have a solution for that. We have a solution that has been in process for more than 5 years now. The technology is very simplistic. It's easy to understand, and as everyone in these security world knows, the simpler the solution, the smaller the threat surface is, and we just have a boatload of benefits, and we would love the opportunity to be able to share the knowledge with anyone out there that wants to learn more.
Of course. No, thank you so much, Bart and David, for participating in Risk Roundup today. We appreciate your thoughtful insight on the autonomous network security, and I'm sure our global viewers and listeners will benefit tremendously from the information you shared about your technology, about your core technology, and what applications could emerge from that. And as a result, I think this Risk Roundup dialogue has been of service, and we thank you for that.
Thank you.
Risk Roundup, a global initiative launched by Risk Group, is a security risk reporting for risk emerging from existing and emerging technologies, technology convergence, and transformation happening across cyberspace, aquaspace, geospace, and space. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. It is not possible to conceive any one of the three without the existence of the other two. All three concepts fit into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security. So if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the Risk Roundups, to watch the Risk Roundup videos or listen to the Risk Roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayshree, host of Risk Roundup, signing off. See you next time. Thank you.